Hi, today we are going to look into how to check the capacitor bank. Okay, here we have, this is the micro power factor regulator. This is the capacitor bank panel. Okay, this is the capacitor bank. Step 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 step. Okay, this is the capacitor bank discharge resistor. It helps the capacitor bank to discharge faster than usual. So the capacitor bank, once it is going to restep back again, it will have less likely any spark or any spark available, which causes the cap bank to reduce lifespan. Okay, so first of all, we're going to look into it here. Okay, to check the capacitor bank, first of all, we take a look at the set cos theta. That means the target power factor value. Here we have 1.00 is unity power factor. Okay, you can program it 0.98, 0.97 or 0.95. Best is put it 0.98. Okay, or you can set it as overcompensate. This is overcompensate on the capacitive side, but we don't recommend that. So it's best to set in the inductive area. 0.98. Here the installation is set at 1. Okay, so press program. Okay, next we have a CK value. CK value is much more applicable if, let's say, you have an installation so big and then you have the CT of 2000 or 3000/5. Then you want the cap bank to be more precise and accurate without overcompensation. Then you can set the CK value. Here we use the ATC. That means it doesn't based on the CT loading factor. It's only based on the power factor value. Okay, so this is the sensitivity, how sensitive it is. Once it detects there's a undercompensation, how many second delay before it cut into the step. Okay, then here we have the reconnection time. After each step is on, then off again. If you want to reconnect back, how long it delay. This time also considering how fast and how soon the discharge resistor discharge the the capacitor bank before it cut in again. Okay. Then we have the rated step. Rated step, normally it will show you 0 if, let's say, that step itself is faulty. This depends on how you set the CK value. If your CK value is set at ATC, this one will determine whether the step is alright or not. If your CK value is set at a certain value, this one you can set to 0 or to 1. You can choose whether to allow the power factor regulator to on your step or not. Okay, now we go to the switching program. Okay, press program, and when here is blinking, you choose to NA, manual mode. Then we put program. Okay, now it's under manual. Okay, once it's under manual, we just on the step. First step, second step. Okay, first step. Okay. Alright, now all the capacitor bank step is on. Alright, this also determines all the capacitor bank is in good condition, contactor is in good condition. Alright, okay, then another simpler way to determine the cap bank is okay or not, you just use the clamp meter. Okay, this is a clamp meter, so we just check the amp, either two phase. Okay, once you determine the amp of each step, then you can know the step there's an output kVAR there, so it's not faulty. Do bear in mind that Alright, do bear in mind that the amp can reduce based on the efficiency of the power factor itself of the capacitor bank. The longer you use the cap bank, the amp will go lower. Okay, so now here you have it. All the capacitor bank is in good condition. At the same time, try to check the color of the PVC insulation here. If let's say the color becomes darkened, that could means there's a loose termination. The temperature of the cable goes above 60 degrees Celsius. That's why it causes the PVC insulation color to change. Alright, here we have it. After checking everything is in good condition, now it's still under normal. Okay, you can still, manual mode, switching program. You just press program. Once this one is blinking, shift it back to auto and program again. Okay, once it's under auto, the power factor regulator itself will switch off the steps automatically, one by one. Okay, so as you shift this one back to the power factor value, now it's overcompensation, so that's why it's on the capacitive side. Okay, as step by step switching off, this value will go back to the target power factor value. That means it's 1.00. This is what the PFR will try to do. It will try to adjust the power factor by cutting in or cutting out the steps to maintain the power factor value. Okay, now one by one, cutting in and cutting off. Alright, the value is going back to the 1. So the overcompensation will go back to normal. There will be time delay. Alright, now it's almost back to 1. 0.99. It stopped here because the power factor value is quite close to the actual target power factor set point. Okay, this is the set point. It's quite close. Okay. Alright, so we are done here.